So hi guys, this is Chandrakishore from CSE BDE section. So I am going to take a class of Missionary and Cannibals. So with my teammate of Raja Harshavardhan, today is with his absence. So yeah, we can go now. The Missionary and Cannibals puzzles. This classic logic puzzle involves a group of three missionaries and three cannibals who need to cross a river using a boat that can carry at most two people. The challenge lies in ensuring that the missionaries are never outnumbered by the cannibals on either side of the river. So this is the main overview of the missionary and cannibals puzzle. So yeah, we can go on to the next. Defining the constraints. So capacity of the boats. It must be a maximum of two numbers, one or two members and go with the yeah. The boat can carry only a maximum of two people at a time. Safety requirement. Missionaries must never be outnumbered by cannibals on either side of the river. Boat movement. The boat cannot cross the river by itself with no people on board. So it cannot cross the river without no people on the boat. So whether it cannot float with no no one is there on the boat, so it cannot go with that. The initial state, starting bank. All six people combines three missionaries and three cannibals are on the same side of the river. Boat position. The boat is also located on the starting bank, ready to transport the people across the river. So the starting is means left side of the river, and it crosses across the river going to right side of the river. Goal. The goal is to move all six people to the opposite bank of the river while ensuring the missionaries are never outnumbered by the cannibals. Okay, these are the initial state. So now I'm going to talk about possible moves. So there are two missionaries can able to travel in the boat to cross the river, or either one missionary or one cannibal can able to travel, or two cannibals are able to travel across the river to cross the river. Yeah. So developing the solution strategy, maintain balance, ensure the number of missionaries and cannibals on each bank remains balanced to avoid the cannibals outnumbering the missionaries. Prioritize missionaries. Focus on moving the missionaries across the river first, as they are the most vulnerable group. Minimize crossing. Optimize the number of boat crossing to efficiently move all six people to the opposite bank. So yeah, from left side to we have to cross the river to the right hand side. Logical thinking. Carefully consider each move as its implication to ensure the solution is valid and safe. Yeah. So yeah, implementing implementing the solution now. Step 1. Send two missionaries across the river. Step 2. Send one cannibal back to the starting point. Step 3. Send one missionary and one cannibal across the river. And step 4 is send two missionaries back to the starting point. And step 5. Send two cannibals across the river. And step 6 with send one missionary across the river. So yeah, next one. This is the main thing that so we have six people. So that means three missionaries and three cannibals. So one missionary, so yeah, one missionary and one cannibal are travel into the boat, and one cannibal is dropped to the right side, and one missionary return to the left side, and the remaining two cannibal are moved to the boat, and it drop one cannibal, and it move on to the and return to the left hand side, and again now go on to the missionary. Two missionary can able to travel into the boat, one replace with the right side and return to the left of the boat, and again it carries two missionaries. Okay, two missionaries and kept two missionary and pick up cannibal into the left hand side of the boat, and two cannibals there. So here three are there. So two cannibals can able to pick up to the boat, and it drop one cannibal, and one cannibal are returned to the left hand side of the boat, and two cannibals are there. So finally, the two cannibals are go on to the boat and drop into the right hand side of the land. So this is the solution for three missionary and three cannibal problem. So yeah, we can go on to the conclusion. The missionaries and cannibal puzzle is a classic logic problem that challenges us to think critically and develop a strategic solution by carefully considering the constraints and implementing a step by step plan. We were able to successfully move all six people across the river without compromising the safety of missionaries. So, yeah, these are the things that we have done in missionary and cannibal. So, yeah, I'll finish up to this. Yeah, thank you.
Good afternoon, everyone. I am Harshavardhan, here with my teammate Chandrakishore, and today we are going to talk about the AI toy problem of missionary and cannibals. Firstly, let's introduce our problem, the missionary and cannibal problem. This problem is a classic river crossing logic puzzle, where the player has a total of 6 pieces, 3 missionaries, 3 cannibals. The goal is to make sure to get all 6 pieces across the river using a boat which can carry at most 2 people, under the constraint that for both banks of the river, the number of missionaries cannot be outnumbered by the number of cannibals. So, what this means is basically if one missionary is on one side of the river bank, at most there can only be one cannibal present. Now, let's look at the state problems, search problems for this specific problem. Search problems. The number one is initial state. We must define the initial or start state. In this case, it's the 3 cannibals and 3 missionaries on one side of the river, be it left or right. Second, set of actions. So, for a set of actions, all possible actions that the player can play are defined as action, comma state. So in this case, if we move 2 cannibals, we can define the actions as 2C. This is to define the game state and the state space path, which in a nutshell is our final output. Number 3, our goal state. As the name suggests, the goal state is that all cannibals and missionaries have reached the other side of the riverbank, and finally, we move on to path cost. So, path cost is the time or effort taken to reach the goal state in the most optimal way to do so. It is what we are looking for in this specific toy problem. Let's look back at the second point. Set of actions. So here, set of actions, given that the initial state is defined, here as all pieces of the game are on one side of the bank. We can now define various actions. These actions may vary as the following. Firstly, one missionary crosses the river. One cannibal crosses the river. A missionary and a cannibal cross the river. 2 missionaries cross the river. Or finally, 2 cannibals cross the river. By defining each of these actions, we are defining a new game state every time. Each game state can either be a loss, as previously mentioned, where one missionary crosses, leaving 2 missionaries and 3 cannibals. Given that the cannibal number outweighs the missionary number, we have lost the game. Or a win, in turn leading us to the development of our space path. In the following, we have the path from the initial state to the goal state, from left to right. Given our goal is to make sure all missionaries and cannibals have reached the other side of the bank, we can define the following. We eliminate all possibilities where we end in a lost state, ending with this state space path with the most optimal outcome. Now, my teammate Chandrakishore will explain the alternative ways to derive this specific goal path.